Okay, today we're going to look at lesson 14, and we don't have an objective or a learning target today. We're just going to look at some more things related to linear equations. Now, some questions on your homework are review questions from other lessons, so I'm not necessarily going to go over those again in this lesson. We're just going to hit some things that you haven't seen in some previous lessons that you'll need for today's homework, okay? And we're going to start with correlations. Okay, like I said, we're starting with correlations, and we have some vocabulary. Now, the only thing we're going to really do for correlations in the lesson is just look at the vocabulary, and you'll have to use the vocabulary in your homework. So I recommend that you pause, write down the definitions, listen to my explanations, and work through this. So first we have a scatter plot. A scatter plot is a graph that relates two different sets of data by displaying them as ordered pairs. So you have a list of data for X, a list of data for Y, and those are turned into ordered pairs and plotted on a graph. A positive correlation is when Y tends to increase as X increases. So as X gets bigger, so does Y. And this is what a positive correlation could look like. You can see a definite pattern going up to the right. A negative correlation is when Y tends to decrease as X increases. So as X, and I wrote a zero though, as X increases, Y decreases. And that gives you the slope, this negative slope down to the right. Okay, a negative correlation is when Y tends to, sorry, I just said that. So sorry. No correlation is when Y and X aren't related. You can't see any pattern in the graph. The points are just kind of everywhere. You can't say, oh, it's a positive increase or a negative increase. It's kind of just all over the place. And then our last definition is causation. When a change in one quantity causes a change in a second quantity, we can call that a causation. Now, a correlation between two quantities doesn't always imply causation. And that's something you're going to have to think about in your Math Excel homework. So you're going to be given some scenarios, and you have to think about, you're going to have to decide if the two quantities would be a positive correlation or a negative correlation. So you're going to have to think through some things and use some logic. But then causation, so let me give you an example. If you're comparing summer temperatures and ice cream sales, well, and you notice as the temperature increases, so do ice cream sales. That could imply causation because when it gets warmer, people like to get ice cream. Okay. Now, if you were comparing, and that would be a positive correlation. One's going up as the other one is going up. Now, if you were going to compare inches of rain and Pepsi sales, and you saw as Pepsi sales increase, the inches of rain decreases. You might see a correlation there, but they're not really going to be, it's not going to be a causation because there's nothing really that you can say that more Pepsi sales cause more rain, or more rain causes more Pepsi sales, or less, or you see what I'm saying? Like, they're not related. You're probably not going to find a causation, but depending on what month you look at, I mean, you could see a correlation there, but that doesn't necessarily mean causation, okay? So again, you're going to have to think about some scenarios and decide if you think it would be positive correlation, negative correlation, no correlation, like you don't think they're going to be related at all, like, I don't know, book sales and coat sales. Those would probably not have a correlation. They're probably not going to line up. Maybe, but probably not. So you're just going to have to think through some scenarios and decide what you think. And then remember, just because there's a correlation does not mean there's causation. Okay, next we're going to talk about horizontal and vertical lines. You should already be somewhat familiar with the horizontal and vertical lines from talking about slope and linear equations, but these problems might look a little bit different. You're going to be given an ordered pair, and you're going to have to decide what horizontal line passes through the point and what vertical line passes through the point. First, we need to know some basic information about horizontal and vertical lines. So we know a horizontal line goes left to right. With the horizontal line, you do have a y-intercept because it does intersect the y-axis, but no x-intercept. So it runs parallel to the x-axis, so there's no x-intercept. They do not touch. The equation is y equals a number, okay? So that's the y-intercept, and your slope is 0, so that's just a horizontal line. A vertical is the opposite. Vertical line is up and down. You have an x-intercept but no y-intercept. That means it never touches the y-axis. It runs parallel. The equation will be x equals a number. You put that point on the x-axis and go straight up and down. And if you try to find the slope, it will be undefined. You'll have some number over 0. Okay, in Math Excel, you're going to be given an ordered pair or a coordinate point, and you're going to be asked for the equation of the horizontal line and the vertical line that pass through that point. Okay, and then I can't remember if you have to graph or not. I think you do, so we'll look at that as well. So for the horizontal line, if it's going to go through this ordered pair, let's think about horizontal. We know that horizontal, it's not going to have an x-intercept. It's going to be y equals some number. So what y value do we know that it's going to go through? -6. So y equals -6 is your line. And if we were going to graph that on a number line, you would just go down to -6 on the y, and it would be straight across. Okay, vertical is x equals a number. So what's our x value? 9. And if we were going to plot that on a graph, you would find 9 on the x-axis and go straight up and down. And so if you were graphing these on the same graph, they would meet at the point 9, -6. So somewhere down in here. Okay, the next thing we're going to talk about are parallel lines, perpendicular lines, or neither. So you made some equations of parallel and perpendicular lines, but we haven't identified parallel and perpendicular lines yet. So that's what we're going to do in this section. First, we have parallel lines. Parallel lines have the same slope and different y-intercepts. So that means they're going up or down at the same rate. They're going to look very, very similar, but they have different y-intercepts, so they're never going to intersect. This is an example of parallel lines, equations of parallel lines. The slopes match, the y-intercepts do not. Next, we have perpendicular lines. Perpendicular lines have opposite reciprocal slopes, and the y-intercept really doesn't matter. It can be the same or different. Opposite refers to the sign, so positive and negative. Reciprocal is when you turn that fraction upside down, okay, or you turn that number upside down. You do 1 divided by that quantity. So here's an example. We have y equals 2x minus 8 and y equals -1/2 x plus 4. So the opposite of positive is negative. The reciprocal of 2 is 1/2. So those are perpendicular because they have opposite reciprocal slopes. Okay, last we have neither. There are 2 ways you can have neither. If you have the exact same line, then it's going to be neither. Because parallel, they have to have different y-intercepts. So here we have 1/2 x plus 2 and 0.5 x plus 2. Those are the exact same line. Their slopes are 1/2, your intercepts are 2. So that means when you draw them on the line, on the graph, they are going to overlap in every single location. So they can't be parallel, because if they're parallel, they never touch. And let's see, we should add that in here as a little note. They never touch. Perpendicular, they have one intersection, and it makes a 90-degree angle. Okay? So, the same exact line, it overlaps everywhere, so it doesn't meet either piece of criteria. All right, the other is if it's not parallel or perpendicular. So they're not even close, they're not related. So we have 6x plus 3 and negative 2x minus 6. Those slopes are not the same or opposite reciprocals. So that would just be neither. Now in your Math Excel work, you are going to have to decide whether lines are parallel, perpendicular, or neither. So make sure you know the criteria for each one. Next, you're going to have to decide if a function is linear or not. That means, is it a straight line, yes or no? So if we look at number 1, is that a straight line? No. Number 2, yes. Number 3, yes. And number 4, no. So those are pretty self-explanatory. You probably could have done those without me giving you any help there. But linear function means it's a straight line. And for it to be a function, remember, a vertical line can only hit the graph once. If it hits multiple times, it is not a function. Okay, the last 2 little things are really quick. One, I just want you to know that you will have to use some interactive tools for some of the problems. Like there's some little sliders to pick the slope and the y-intercept. You can move the graphs around. There are some different things, but there are some interactive tools that you need to use. If you need help with those, just let me know. But I think you guys will catch on pretty easily. And then last, you have a question about quadrants. I think you have to look at a graph and decide which quadrant the line does not go through. So just in case you can't remember, these are the quadrants of a coordinate plane. You have 1, 2, 3, and 4. So in quadrant 1, all your points are positive. In quadrant 2, you have negative x but positive y. In the third quadrant, you have negative, negative, and in the fourth quadrant, you have positive x and negative y. So I think you just need the quadrant numbers, but there's just a little reminder about quadrants. Now, I know this video was short and it was quick, and it didn't really go into a lot of depth about each of the different things. But again, this lesson is a review. This homework has some review stuff, and I think you'll know how to do most of it anyway. But this was just a little video to help you if you need it. All right, so use this to do homework 14 in Math Excel. And as always, if you need help, have questions, let me know. Stay in the Google Meet, send me an email, hit the Ask My Instructor button, whatever you need to do. And have a great day.